Hey everybody, this is Larry. This is day 29 of the Leetcode Day Challenge, and we have a weekly premium challenge after this. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Man, it's a tough, sad day. The Rangers lost in overtime. It was a very exciting game, but some days, some things, they're just not meant to be, right? I was a little bit tired. I just got out of the shower, running like 9 miles or something like this, and it's very hot. I am very hot. I don't have a. I mean, I have an air conditioner, but it's in the other room. But also, there's still like, I don't. It's already almost June, and I still have crazy allergies. So I'm trying to like keep my bedroom and my not bedroom like separate, you know. And as a result, like, but my air conditioner is only in the bedroom, so I don't want to get all the pollen everywhere because I'm trying to do like a almost like a bubble boy situation in the bedroom. But in any case, it's very hot. That's what I'm gonna say. So let's do this form quickly. So I'm gonna go back to the AC afterwards. Let's take a look. 1404. Number of steps to reduce a number in binary representation to 1. Given a binary representation of an integer as a string s, return the number of steps to reduce it to 1 under the following rules. If the current number is even, you have to divide by 2. If the current number is odd, you have to add 1 to it. If it's guaranteed that you reach 1 in... can you just do it? I mean, the length is 500, but that's fine. So you could just simulate it, I think. Like, why wouldn't you? This is a rule, but the reason why you can just simulate it is because if it's odd, then you just add 1 to make it even, And if it's even, you divide by 2. So that means that for every 2 operations, you're gonna reduce it by it's an anyway, for every 2 operations you remove a digit, right? Basically. So, and given that you only have 500 digits, it's going to be like 1,000 operations at most, in theory. The tricky thing, of course, is that you're given a string representation, which I didn't really notice. And I think back in the day, back in the day in the old competitive programming world, and even some interviews, and I mean this as in like, what year is this? 2024, like maybe 10 plus years ago. So definitely a long time ago. And sorry, I'm like, my mouth is way scratchy because of the allergies, like I'm saying. So if I'm like struggling talking, that's why. The medication does not help. But in any case, so big int operations and stuff like this that we're very familiar. And the thing then, if you want to think about it that way, I mean, we could play around with this a little bit, at least talking about it. Then the add 1 operation is kind of tricky. Because then the add 1 operations can... No, I mean, that's not even that bad, to be honest. The reason why it's not that bad is because how many times can you... Like, basically, because the idea here, or the idea that... The idea here is that, because if you interpret this naively, right, and you have to add 1, you could say, okay, well, adding 1, there's going to be carry n times, so then we do this operation n times, this is going to be n squared. Which, just to be clear, given that n is 500, is still fast enough, but it's just something that you have to consider, and especially if you're on an interview, you have to point it out, probably. But on a closer look, or a closer think, because I didn't really look at it yet, is that that's not true, right? Because amortized is going to be O of n all together, because basically you have like this is probably, I don't know if this is the worst case, but this is one case. If you add 1, this is all going to flip to 0, and then that's it, right? So there's not much to be, because, well, I mean, it is what it is, right? Just flip them all to 0, except for add 1 in the beginning. But let's say what if you have a 0 here, right? Well, you're still going to flip all these, the first time you're going to do it, you can flip all these to 0, and then flip this to 1, right? And then these are all zeros. And then the next time, after you remove zeros 1 at a time, which is divided by 2, you have a 1, and then now you flip all the other ones again, right? So that means that at most, for each digit, you're only going to carry once, and that makes it O of n in total. So even if you have something funky, it'll be O of n. Like if you have your own big integer implementation, which back in the day, that is the idea behind this problem. I mean, otherwise they, if you're using Java, you could have a big integer class. I think it's called, is it big nums or big int? I don't remember anymore. It's been a long time since I did Java. But Python, obviously, you can just use it, and it'll make the problem a lot easier, of course, because you don't have to do big int. But if you see this in an interview, obviously ask and communicate. But chances are, if you see this on an interview, they want you to, do it without a class like that. So definitely, if that's important to you, practice it a little bit, just in case, just so that you know how to do big int. But that's only if you want to do big ints in a very straightforward kind of way, right? In that, like, you just kind of do the operation, because you don't actually need to do big int on this one, it turns out, right? Because as we said, we only need to add one, and we only need to add one bit at a time, and so that there's only one carry bit. So here now we can just do it backwards, and you have to be a little bit careful, a lot careful, but that's the idea, right? So then now you have four. You just have to do it backwards, and then make sure that you do the carry bit carefully. So let's see if I could get it right on the first go. To be honest, these things are always very sketch for me, so we'll see. But yeah, but basically, okay. So then now, if s of I is equal to 1, that means that it's odd. Then you increment, right? And by incrementing, you do an operation. Yeah, you do an operation. Now carry is equal to 1, right? Okay, let me rewrite this actually. This is a little bit not generic enough. So then d for digit is equal to s of I, right? Cast it to int, and then now we add it to the carry. We set carry. We set to carry, right? And now we set the carry to 0 because we already used it. And then now, actually carry is not used. Carry is equal to d mod 2. No, it's d divided by 2, right? Because basically if d is 2, I'm really bad at adding today apparently, so it is a good practice, I suppose. And then d we just multiply by 2 because, divided by 2 to, wait, do we? So if d is, yeah, because anything bigger than 2 we carry, right? So then now we ask, if this is 0, then we're good. So then we don't do anything. It's just, count increment by 1 because we divided by 2. If this is 1, however, then now we have to add 1 to it, right? And then now carry, we add 1 as well. Because then now we add 1, now there's a carry, now it's a 0, and now that is a 0, then the invariant here is going to be d is equal to 0 at this point, kind of. I mean, in the way that it flows. And that's pretty much the idea. And then if carry is equal to 1 at the very end, then we increment again. Wait. Oh, reduce it to 1. Okay. Because I was like, you can't reduce it to 0. So I had to think about this a second. I mean, it should be obvious, but I'm trying to think for the last case. So then the last digit is always going to be 1. And then we just ignore the carry then, right? I think that's maybe good. Maybe I'm off by 1. Let's take a look, take a spin sees with a few cases, and let's just do right? And then 1. Okay, so we're very wrong, or at least somewhat wrong. I'm not surprised that 1 is wrong, or it is wrong for the number 1. Is it wrong for the other one? It is also wrong for 3, huh? It's okay for 5 though. Okay, so why is it wrong for 10? Oh, I give 3. I always confuse expected and output. Okay, so I give 3. Why did I give 3? So 1, 0, then we 1. Oh, because we look at the last digit. Last digit is going to be 1. If this is 1, then but Hmm. Huh. Because I want to skip the last digit, but we can't because we have to consider it for the carry bit, right? So, okay. So maybe something like if I is equal to 0. No, I guess we'll just take it out. So here, we'll take it outside. So then we assume that the last one is going to be a 1. So if there's going to be a carry, if carry is equal to 1, that means that we take the last digit, which is a 1. It has to be because there's no leading 0. And then make it a 2. So then now we have an extra thing. Okay. Alright, let's give it a submit, though admittedly not super confident because a lot of silly mistakes can happen. But looks good. Streak at 1520. And yeah, what's the complexity here? This is going to be O of n times and O of 1 space. You could kind of look at everything here, right? There's an O of n loop and O of 1 space because we only have, what, like 3 variables, 4 variables, something like this. And yeah, that's all I have for this one. I don't know what to make of this, but it's pretty okay. Let me know what you think. I mean, I'm trying to. I do wonder. I mean, so I did it by simulating, but I wonder if there's like a more mathematical way of doing it. Every time you see a 0 is 1. Every time you see a 1, what does that mean? I don't know. Like, can you do it with? Is there like a way to do it with the number of 1s? I don't know. Like every time you see a 0, that we just get rid of it. But technically. Well, this 1 kind of shifts it, but that's fine because it just shifts to 1 to 0, right? No, but then it keep on going. I don't know. I am curious. Let's cheat. Is there a more mathematical way? Oh, greedy. What does that mean? I mean, I kind of simulated. I don't know. Greedy could mean anything. I mean, this is basically what I have, right? So, though their code is really kind of nasty, but really weird looking. But I don't know. I consider my simulation, but I guess their simulation is literally adding 1. So okay, I see what they mean. But again. But their analysis is wrong, right? Because we already talked about the simulation. I mean, I guess you can do it simulated in a really bad way, but the simulation is actually O of n, right? Because like I said, each digit only goes from 1 to 0 once. So, and only once from 0 to 1, right? So, because you only go from 0 to 1 if you have a carry, and you can only go from 1 to 0 if yeah, and the last digit or whatever, right? So it doesn't. No, I don't. Because you can't change each number twice. So this is O of n. I think the analysis is just wrong. Yeah, I don't know. I mean, maybe I'm wrong. I don't know. Who knows? But that's all I have for today. Let me know what you think. Thanks for watching. I'm going to do the premium bomb afterwards, so stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.